Hello, I'm Javier Gonzalez, Unreal Engine Authorized Instructor, and today we're going to see a brief introduction to interfaces and polymorphism. This is a really wide topic, and there's a lot of good talks about it in Unreal Engine's official YouTube channel, as well as some performance related good tutorials there. But today we're going to see the base of it and how can we apply it to a new project and how can we fix potential issues that comes when you're a beginner or you don't really have like a big grasp of programming in general. So let's get to it. My bad about my cam sometimes glitching. My OBS is behaving in a strange way lately, but you get the drill. Okay, so let's start first with the lesson outline. First, we're going to learn the use and utility of interface. Then we're going to see the cast too. I'm pretty sure that everyone has heard the casts are bad and so on. That's not completely true. There's some good videos as well as in Unreal Engine's YouTube channel about it. But we're going to see and spot in an early stage a hard referencing issue using the reference viewer and the size map, which are really good tools that are not always exposed in tutorials. Then we're going to see a brief introduction to polymorphism, which is an object-oriented programming principle. It's really useful, and many of you might already know it without knowing that you know that it happens a lot in programming when you go from language A to B and so on. And then we're going to see the use cases of interfaces and polymorphism and the cast on how referencing issues in an exercise that we're going to fix those issues. So you know what to do at the end of the lesson when you spot this in your projects. And then we're going to see the outcomes of the lesson. It's pretty much clear. So first, I'm going to start a new project, and I'm going to program without using this, and then we're going to see what are the issues this approach will cause. So we're going to start by using the cast2 and the how references. It is the easiest way for classes communication, but it causes hard references issues that we're going to see it in the reference viewer and the size map. Um, of course, it also brings potential scalability and memory issues and increases classes dependencies and goes against decoupling. Decoupling is a really well-known principle in programming. It means that class A, if it shouldn't work really tight close to class B, they shouldn't have any direct relationship. We're going to see this, but if you guys want to dig more into this, I really recommend you to read about the solid principles, which are the angular stone for every programmer all around the world. So let's get into it. Okay, I have my project here. It's a third person template project. I just added some code to do a trace that we're going to use in this. So I'm going to delete this for now because I had some code here before, and I'm going to quickly explain the code behind this. So first, we need a socket. This is a trace that it's basically array cast, as some people from Unity say, that goes from point A to B and detects any potential collision between those 2 points. So what I did here is that in my mesh, in the default mesh that comes with the template project, I added a single socket in the head around the eye's height. I'm going to search for it. Oh, sorry, the ones that comes with the project. Here it is. It's an eye socket in the head, in the bone head. So we're going to take the location from here, from this socket that's around the head, and it will start there. And then we are going to do some quick math based on the forward vector. So it's going to go from the point A 1,000 units forward, and that will be the end of the trace. That's what we can see here. You see, it goes there, but if it's too far, we won't have any collision unless I go closer. This is a really this boilerplate is scattered all around the web. It's really easy to find, and I recommend you guys to always have it noted down. Okay, so based on this, what we want to do is we want to create a real simple interaction system. I want this to have I have these two actors. These are a real basic actor. This actor has a particle system deactivated and a point light with zero intensity. I mean, it's not activated here, but I want this to lit up when I interact with it, and I want to activate the particle system on interaction as well. So this is not auto activated; it's deactivated by default as well as the light. But how do I communicate with this? I made a custom event, which is the most simple way of doing an interaction. With this flip flop node, what this does is the first time that it activates goes in this in the A way and the next time that I do an interaction or call this custom event, it will go B and so on. So the first time I interact with it, the polylight is going to get intensity and then it's going to activate the particle system. And the next time I interact with it, it's going to turn off. So the intensity will go to zero and the particle system will deactivate it. I did pretty much the same with this chest. But what I'm doing here is that it has two meshes. Oh, I added a collision box for this to work. No fancy stuff. So it has the body and it has the top. And what I'm going to do on interaction is that I'm going to do this movement on the y-axis and so on with the same setup I did with my light and fire. So what's the issue with this? I want to be able to activate this with this trace, but I don't have a way to say, hey, this is a chest, or hey, this is a light I want to activate, I want to call this function. Because what this does is that in the outhead, if it was a successful hit and it detected something, we have this hit actor, and it was called HR because it goes for hot reference. It's called HR interaction on the light blueprint, and here interact chest. But I don't have any access to this, like HR interaction. I don't have any way of knowing that the hit actor is that actor that I need. So here, what I should do on the base setup is that I should do a cast too. I was called BP fire calls, and then if this cast succeeds, I have access to the HR interaction. But here comes the problem. Here comes what people call a hot referencing. What does this mean? Okay, first let's go to our PP third person character. Let's see the reference viewer. We're going to see that we have this comes by default, but this means that this actor is referencing all of this content. What do I mean by referencing? Is that when this actor is loaded, all of these classes and assets are instantly loaded just because this references this. And what does that mean? Okay, every asset uses spaces in memory in runtime. You can see how much an asset uses using the size map. Here we can read that this uses 36.3 megabytes. This is different from this size to memory size. Memory size will always be lower because this is when the asset is cooked and packaged. But this is a different talk. We're going to see with this for sake of simplicity. But you can see what this references, and it goes by levels. You have here in the reference viewer that is referencing the anim blueprint, but this also in chain references other assets such as all these animations. So this means that just by using a cast, you create a hard reference. What does this cost? Okay, let's see. The BP fire calls have the size of 70 megabytes. It's almost twice as big as our main character. But let's see what happens when I do a cast. Just by this HR interaction, Look at this. Oops. Let's wait a bit until it takes some time sometimes. Size map. Now we see it's way heavier, just because now it has this PP fire calls heavy reference, and it weighs almost 100 megabytes, which is a lot of increasing in the base size of the character. See, just because I'm using a cast, it easily loads the BP fire calls, which loads the call meshes, the particle system, and everything that relates with it. So it's really unnecessary. We shouldn't have this issue. You can confirm it that on reference viewer. Now here we have a hot reference to it. And okay, now it's 100 megabyte. It's not a big deal. But what happens when your project escalates and you have thousands of actors and those actors references all other assets, and you're gonna end up with a player of at least 10 gigabytes, which is a lot. So yeah, that's a real no go for development. But it works. Here, for example, oh yeah, we already saw this, that on interaction I'm going to lit up the actor and activate it. So we can go here. I'm going to do my cast. Oops. And it works. There's a particle system, and when I hit it again, it's deactivated. It works as intended, and it does what we want to do. But what happened with the chest? Okay, now I have the same issue. I'm hitting the hitbox of it, so it's detecting the actor itself. But here we should have this set up. Okay, so when I hit the chest, it's not going to be a fire call actor. So we will have to do this, like cast to chest. And if this is the chest actor, now we can call the HR interaction chest. And now it will work. But we will end up in a real game scenario. We will end up with 1,000 of different actors here, and they play a reference in all of them all, and ending up like being a giant monolithic class, which is really bad for development. And we don't want this. We just want the functionality, but not what it brings to us with this current setup. So what we can do, I have a solution for you guys. So yeah, we saw this. We already did this, but we spotted the issues. Of course, it creates references viewer and size map increasing. It's a really unflexible system, because if I add another interacting actor, let's say, I don't know, a coin bag, I will have to reference that in my main character, and no, it's a big no. It creates dependencies that shouldn't exist, as we just saw. Like it creates a dependency to the fire collector and the treasure chest. Well, that shouldn't happen. And of course, the maintenance issues. When we have a really big game, we have sometimes to maintain some classes or refactor some of them, and these dependencies goes against that. If I modify in that big setup the treasure chest, then I will have to fix the main character, and that will create a chain of maintenance issues and bugs and so on. So yeah, this is a really simple setup for an interaction system. It works, but things don't have to be done this way. For this, I have a solution for you that's called interface. What is this? It's a communication contract. I always put the example of the remote control on television. Why? Because let's say we have a generic remote control, and it will work with every class or kind of television. I know there's sometimes some, for example, Samsung controls that only work with a certain type of television, but I'm putting here the example with a generic remote control. So that's what we're going to do. The benefits of this is that it's going to be 100% decoupled communication between classes, and we're not going to have this hard referencing and extra megabyte size classes. It's going to be this interface function, or this interface itself is going to be the generic remote control that's going to work with every actor that implements this interface. And okay, let's see the content. After this, we're going to use polymorphism. What polymorphism is? I'm pretty sure that you guys know it. If you don't know it, I'm pretty sure you know it if you're a programmer. The polymorphism is that we have a parent class. Let's say in this example I always put it, let's say we have the class animal. All the animals, almost most of them, make sound. Here we have the sheep, the frog, the lion, and the owl. That they can implement this speak function. This speak function comes from the parent class name animal, blue BP underscore animal. We will have that defined there. But all these small classes that will be inherited from the parent class will come from the BP animal class, will also implement by default this class. And this will create an override because the sheep will just say with a printf with that, and the frog will say ribbit. It's going to have the same exact name of the function, but they are going to do different things. But it's the same function. That's called polymorphism. That it means that one thing can take a lot of shapes. And that goes to our next point. That is the architecture planning. That's something I really want to point out because it's really, really, really important in real world development. Is the power of polymorphism and interface function. For example, in this case, we will create our blueprint interactable class. This that's going to have the interact function defined there, and we're going to implement that interface in our BP underscore base interactable class. Um, all the other classes, such as the call, blueprint, and the chest, and another one that we're going to make at the end of this video, are going to be child classes from this blueprint interactable class. That's going to have this interface already integrated into it, and also is going to have an interaction effects for visual effects, for example, for the same fire spawning, or some loot effects for the chest. That's going to be inherited from the main class, and it's going to be a use case of polymorphism. Of course, it could be also a blueprint interactable interface function, but for sake of knowing, I'm going to make it a polymorphism class, and we're going to override it. It's really similar, but the use cases might differ depending on the context or what kind of classes you're doing. But it's always good to know that you have these two choices when planning your architecture, planning your classes, and implementing them in the engine. So yeah, here we're going to centralize common logic in the main class, such as what the class should have, what members, if it's need to have a static mesh, member variable, and so on. And then we start creating the different types of interactables items. And in the main character, we just call the interface function interact, and we're not going to have any hard references, and it's going to work the same way it's working now. So let's get into it. First, this is the things we have to do right now. Interact will be an interface function, as I just said, and interact effects will be an overridden function using polymorphism, and then we're going to create an explosive barrel or something else, depending. I think we have a barrel in the sorry content. So let's get to it. First, we're going to create a blueprint interface. It's really easy. You just go here to blueprint class. Oh, I think it was miscellaneous. No, here it is in the blueprint category. Blueprint interface. A blueprint interface is a collection of one or more functions, name only, no implementation, that can be added to other blueprints. These other blueprints are expected to implement the functions of the blueprint interface in a unique manner. Pretty much the same we just said before. By the real convention, this always goes with an I underscore or BI underscore, and we're going to name it interaction interface. Okay, here's our interface function. I mean interface blueprint. If we open, we have a really empty class, and here we create the functions we want our interface to have. And we're going to create one called interaction. It's not going to have any input or output. It's just going to be this. And now we need to create our base interactable class. Because with the current setup, you can see here the treasure chest is just it just inherits from Acta, same as fire calls. So if I do my function, as I said here in the tasks, that's going to use polymorphism, we need to have a parent class for it. So a really correct setup will be that we create a blueprint class based on Acta, and we call it VP underscore interactable base. Okay, this is going to be an empty class. For sake of simplicity and time, I'm not going to add the different things that they should have, such as a static mesh variable on it. But we're going to integrate this interactable interface on it. How do we do this? Let's go to class settings, implemented interfaces. We see here that this actual class, as pure as it is, it doesn't have any inherited interface. And also it doesn't have any implemented interface, so we're going to implement it here. Here it is, BI, interaction interface. And we see that here we have this yellow cog here. All right, so we also need to create in the parent class the interaction effects function. And this will be just a member function of the class itself, not the interface. Um, so we're going to call it interact effects. And for using the same flip-flop setup we already have, I'm going to create it with a bool input called starting interaction. And this is pretty much the function. It's not going to have anything in the parent class because we're going to override this. Remember that we just saw that in polymorphism, we have the function defined in the main class, and then we define it on the child classes. So it's pretty much the same setup we have here. Okay, we have our base interactable actor class created, and now we need to reparent this class. What does this mean? That this class currently inherits from parent class actor. We can change it here to our BP underscore base interactable or interactable. There, here it is, interactable base. And with this done, now we have here the interact function, and we're going to have override the interact effects as well. So this comes from the parent class. Let's go here and see here we have the interact effects function. We're not going to do it like right now but here you see you have a parent call. This means that if you need something for all the 10 classes to do, that you should define it here in the parent class and call this parent out call to parent function. That's going to call that first and then do your own logic. But we need here to use this as well. This is the interact interface function. We're going to do the same with our treasure chest. We're going to reparent this first to our BP underscore interaction interactable base. We're going to recompile. Now we have the interaction function, and we have the effects as well here in override interact effects. Then we're going to do this at the end, but for now, we're just going to change this to this. We're going to delete our custom event because we're not going to use this anymore. This doesn't create a hard reference. We're going to see that now. We go to fire calls as well. And we have the same setup. And now, here we don't need this anymore. Why? Because with our hit actor, we can call without any cast interaction as a message to the interface, and this is going to trigger this. Wrong EP. That's going to trigger this interaction. And what happens? You're going to wonder what happens if it doesn't implement that function. It's going to crash. No, if it doesn't implement that, nothing's going to happen. It doesn't create hard references and it just bypasses the function call. Okay, let's see what happens. Boop, there we go. Again and again. Same behavior. Oops, I think something happened here. Well, doesn't matter. We're going to fix that later. But yeah, you see, it's same behavior. But let's see our size map and reference viewer. Now it's back to 36 megabytes. It's not 100 anymore, and it doesn't have any unnecessary reference to our blueprint class of the call and the treasure chest, oops, as well as the reference viewer. See, it only has the reference to this new interface, and it's well more optimized. And now we can create different interactable items and actors and so on without having to reference them directly here. And we can just change things in the parent class, and it's going to apply to all the actors. And it's way more maintainable, way more optimized, and way more flexible to create an interaction system. So with that said, let's create a new interactable object using polymorphism. The effects, of course. We're going to use that in our new actor. I'm going to delete this one. We're going to create a barrel. Let's see if we have a barrel. If not, engine story content barrel. I think we don't have a barrel. We can use a box. Doesn't matter. Okay, but now how we create child classes of this? We have to go to our interactable base actor. We right click to it and say and click create child blueprint class. And we're going to create a BP explosive barrel. Engine content. Let's see if we have a. I think I have a starter content here. We have barrel. We don't have barrel. No. But we have an explosion particle effect. We have to wait for the shaders to load. Yeah, we can use this. Okay, so now that we created our child blueprint explosive barrel, we have this class empty, but we can confirm it has the inherit interface by default, and it has the interact effects also for us to override. Okay, so first let's add a collision box for our trace to work. Let's see, collision. The trace is done in the visibility channel, so I'm going to override quickly here the collision settings for that box. Custom block, and we're going to add a. I think let's see what we have here in the starter content. Material, shapes, textures, architecture. I don't think we have something like barrel. Props. No, we don't have something as barrel. Let's just use a cylinder or something. Like add, let's use a sphere. We can make this a bit like this. Let's just imagine it's a barrel. Oops. And this has to be attached to the default scene root. We can make this a bit bigger for the trace to work with the height of the cacta. And okay, let's see if we can put this explosive egg in the scene. Play. Okay, there it is. Now you can see that it's doing nothing. And we're hitting the collision box, and it's an interactable object, but it doesn't have the function itself implemented, and it doesn't crash. It doesn't give any error. It's an interactable object, but it doesn't have the implementation of the function, so the system just bypasses this. Now we have to make the interaction. Okay, so let's go here, functions, interfaces, interaction, and now we're going to use our interaction effects. We're going to override this interact effects, and we're going to call that in our interaction function. We're going to put a flip-flop. I don't know if this is going to have multiple. I don't know if we have like multiple explosions. Let's see. Particles. Okay. I don't know how this one works. Yeah, just make a quick example with this one. Okay. So start interaction, and the other one will be this one. Okay, we're not going to use call to parent function, but we're going to spawn different particles based on this is the starting or not bool flag set here. Okay, let's do a spawn emitter and location, and we're going to use the sphere location, get location, get world location, and we're going to use for the first time we interact with the explosion, and for the second time we're going to use the sparks. Okay, so let's review our current setup. First, in our player, we have the interaction interface function call that if the object that we're hitting with trace it doesn't have it implemented, we're going to completely bypass this. And in our explosive barrel, quotes barrel, it looks like an egg, but you get the point. Here we have implemented this interface function, and we're going to call our overridden function that comes from the parent class that is BP interactable base. Interact effects to spawn a different particle system based on if this is the first time we interact with it or is the second time we interact with it. Now let's give it a try. See, first time explosion, second time it's not spawning the sparks or it's loading the shaders. Oops. Well, let's just put the explosion or the fire. Sphere location. Yeah, there it is. First time explosion, second fire. I don't know why the sparks weren't working, but maybe you can see the flow there. It's first. Okay, so now we have our setup to with this setup we can create a multiple variety of different interactable objects, and it's going to be optimized, and it's not going to give exercise to our player character nor create unnecessary hard references here by using this abstract calling to the interface function implemented on each of the child actors of interactable base that implements this interface. So we achieved this architecture, we created this, and we spotted the issues we had with our first system. So the lesson outcomes here is that we diagnose issues of referencing and dependencies in an already implemented architecture. We got knowledge of polymorphism and interface application, and we refactored our actors. We refactored our actors and created new ones based in our new architecture, which is way more scalable and robust. And we understood the difference between interface and overridden functions with two different examples. For more information about this, you can check the Epic official docs. That's linked here. I'm going to leave the link in the description of the tutorial. And that's it. Thank you, and I hope this helps for your future projects. Bye bye.